unit and also dimension. I'll be showing you guys how to solve dimension, short way of solving dimension if you can know units. That is the question. That is the pattern. If you can actually know units, you can also know dimension. So first of all, we have method of expressing units. What are the methods? Number one, that's method of expressing units. Alright, we have two methods of expressing units. Let's list add the method here. A, that is the first one here is we have name method. Please take note. So let's try to know what name method is. Now sometimes you see some units expressed in terms of maybe force as Newton, you see pressure as Pascal, you see work as joules. Now, whenever you express units with the name of the discoverer, please take note of this. Whenever you express the unit with the name of the discoverer, it is known as what? Name method. Now, whenever you express a unit using the name of the person that discovered that stuff, we call it name method. For example, force as Newton, pressure as Pascal, work as joules. So we have a lot of them, please take note. But what is the why is it that in physics you don't always use a name method here? Why is it invalid? Now, sometimes two persons might discover a particular unit without the sensor in, please take note. At that point, you can't say pop, please take note of this. So at that point, that is actually why name method is invalid. We always use formula method in expressing units. So let's take the next one here, formula method. Formula method. Okay, now what is actually formula method here? Now, when you are expressing units using formulas, listen. Whenever you are expressing unit using formula, that method of expressing unit is what is known as what? Formula method. But it means that before, listen, it means that before you express units using the formula, you must know the formula. Please take this. Let's take a note here. Note that expressing units using formula method, the formula must be known. Note that expressing units using formula method, the formula must be known. So now let's try to write some of the formulas here that will be useful to us here. Number one, we have quantity here. Sorry. We have quantities. We have the formula at this point. So the first one here, velocity. The formula for velocity is what? Displacement over what? Time. Please take note of this. The next one is acceleration. The formula is said to be change in velocity over change in what? Time. Okay, now the next one is force. Force is what? Mass times what? Acceleration. Okay, these are the three we can just treat. Later we can now solve some complex questions. Now, I told you guys that, please don't forget, that whenever you are asked to write any unit, the important method to use is what? Formula method. And whenever you want to express any unit using the formula method, the formula must be known. Please take note. So these are the most important formula we can use for, and later we can now give you more formulas. But this is what you should understand here. In expressing any unit here, again, in expressing any unit again, it means that you must know the fundamental quantities. What are the fundamental quantities with their units? We have mass for kg, right? We have what again? Length for what? Meter. What again? Time for what? Seconds. So now let's try to know all our fundamental quantity, and we can now know how we can make use of them. Let's know our fundamental quantities here and know how to make use of them here. Now our fundamental quantities are, let's take note of this. Here is the fundamental quantity. Fundamental quantity. We have their units here. Now we have, first of all, we have mass. The unit of mass in physics is what? Kg. The second one, we have length. The unit is what? Meter. The third one, we have time. The unit is what? Seconds. So this is what you should know about the fundamental quantity. Now any formula here, listen, any formula or any formula I want to use to express the unit, you must reduce that in terms of this fundamental quantity here. You might either reduce that to mass or length or time. Let's take it. You can either be reduced to mass or length or time. So let's take one example here. Example 1, please. Example 1. Find the unit of velocity. Example 1, please. Find the unit of velocity. Find the unit of velocity. Now, first of all, let's pick up the formula for velocity here. We say that velocity is said to be displacement over what? Time. Velocity is said to be displacement over what? Time. Now, I told you guys that whenever you want to express your formula in terms of the unit, first of all, you use them either mass or length or time. So now let's try to know displacement. Now, anything that is not of mass and time should fall under which of the fundamental? Length. Please take note. Anything that is not of length and time should fall under what fundamental quantity here? Mass. Please take note of this. So displacement can never be mass, can never be time. That means it is going to be what? This class length. And what is the unit of length here is what? Meter over. Now time is time here. Please take note. What is the unit here? Is seconds. So this is our answer here. That is meter per seconds. But I want to express this in a linear form. Expressing this guy in a linear form here, I have to know this law in indices. That if I have 1 over x is the same thing as x raised to what? Minus 1. What does it mean? It means that whenever you are taking anything from denominator to numerator, the sign of the power will change. The same thing in terms of numerator here. Whenever you are taking anything from numerator to denominator, the sign of the power will change. This statement. So there is invisible one here. If I'm taking this s raised to 1 here, from denominator to numerator here, the sign will change from positive to what? Negative. So there is invisible one here. Please take note. I want to take this s from denominator to numerator. What will the answer here be? Meter what? Per what? Seconds. Raised to what? Minus 1. So this is in terms of fraction here. This is in terms of what? Linear form. So you can either use this or use this in the same thing. Let's take note. So let's take the next one here. The next one, please. Example 2. Example 2. Find the unit of acceleration. Find the unit of acceleration. Now, I told you guys that the most important method to use to express any unit is what? Formula method. Now, what is the formula for acceleration? Acceleration is said to be change in velocity over what? Change in time. Please take it. And of course, we have known the unit of velocity here. We say that velocity here is said to be V, is said to be meter per seconds. So anywhere I see velocity, I'm going to write meter per second. So let's replace this. This is equal to meter. This change here means when we have two velocities. That means maybe initial or what? Final. So we can now apply the change here. Now the same thing with this, if you have initial time and final time, we can now apply this change here. But since there's no initial and final here, we just use this V only. That is meter per second over what is the unit of time, this seconds. You replace this. Now I told you guys that in terms of unit, we always express unit in a linear form. So how do I express unit in a linear form here? I have to take this second from denominator to numerator. There's +1 here, and I told you guys again that whenever you are taking anything from denominator to numerator, the sign of the power will change. The same thing here. When we are taking anything from numerator to denominator, the sign of the power will change. So this will be equal to meter per second times, take this guy here, from numerator to denominator, what is this? So from denominator to numerator, what is the answer? Times second minus 1, please take it. Now this is S, this is S. Remember, in terms of units, it will be 1 kg, 1 meter, 1 second. Before your answer, before you get the last answer, please, you must have 1 kg, 1 meter, and 1 second before you get your final answer. And if you look very well here, we are having 1 meter, that is, this one is settled. We are having second, that means not settled. We can now simplify furtherly. So if I have something like this in mathematics, a raised to of n times a raised to of n, we call it law of indices. I have the same base here, but different power, and this is times. What will I do? I add up their powers. This is going to be equal to a raised to of what? N plus n. So let's apply the same scenario here. This is times here, this will be equal to plus meter, or you take only one s here, please take note, you take only one base, you add up their powers, what's the answer? Minus 1, minus 1. So finally, our acceleration here will be equal to, acceleration here will be equal to meter seconds, let's what? Minus 2. This is our answer here. Okay, this is how we express our unit. This is only 1 meter, only 1 second. That means this is the last answer. Please take note of this. So last, for now, let's take the next question, please. First, find the unit, example 3. Example 3. Find the unit of force. Find the unit of force. This is the hint here, this is the secret here. Whenever you know the unit of force, you can know any unit at all, because most of the formula, you can know most of the units, sorry. Most of the formulas are mostly attached to force. So let's first find the unit of force here.